give you like 2019, you can find it. But I do like the idea that Annika was saying about these tiny, tiny squares, these microscopic squares that she referred to. How can we solve that issue? How can we make the squares so that they're a little more manageable? Yes.
You can't really think of it as a physical
Yeah.
sort of term. It sort of has to be an unlimited amount. You have to think about it, it's an unlimited amount of space.
Yeah.
But I want to show you. I want to show you.
It's like abstract.
I want to show you a different way to solve this problem. And it's the first way I solve this problem. This is actually this is a relatively new solution for me. This one that you came up with. This is relatively new for me. This is not how I originally solved it. And I didn't solve it alone. I used this problem. Sometimes I do this. I had a math circle session in Puerto Rico and I used this problem. I had never seen it and I just started solving it. And sometimes I do that. I've never seen problems and I just start solving. If it leads somewhere fun, if I can find it, it's okay. I just want people to see that we are humans. Mathematics is a human endeavor when we think. We don't need to know the answers. We look for answers. The mathematics as the art of figuring things out. So my approach was not this. Some of you had an idea that I liked. Varun had this 6. You said that the idea with Varun and his 6, remember Varun's 6? He had something like this. Varun had something like this. His 6 was like this. He started out with a what by what?
I think it was
3 by 3, right?
Yeah.
It was a 3 by 3.
And then you had a 2 by 2 square in the middle.
It was a 3 by 3. So you started with this strip here,
Yeah.
with this strip here, right?
Yeah. Yes.
So 6 took us to 9 and so on, right? 6 took us to 9 and so on. But look at this. This is 6. This is starting out with a 3 by 3. If I start out with a 2 by 2,
That's just 3.
It'll work.
or let's look, I'm sorry, I wrote 3 by 2, thank you. I want to look at a 4 by 4 too. I want to see if I can use this idea. I want to use if I can extend this idea. Let me start out with a 4 by 4. So this is the first time I solved this problem. This is how and since you guys were so fast, I'm going to share something and see if you can finish it. So if I start out with a 4 by 4, this is, well, hold on. So if I start out with a 4 by 4, what do I have?
8.
8, right? Yeah, 3.
Oh wait, it's times 2.
4.
It's a 4 by 4, and then times 2 is 8. 3 by 3 times 3 times 2 is 6. So 5 by 5 is 10. Then
They use this one, so I will be generating all the. Do you see it?
Yeah.
The 4 by 4. Maybe I should do it. Do you see it? This is a 3 by 3. The 3 by 3 gives me the 6. The 4 by 4 gives me the 8. The 5 by 5
Gives you 10.
gives me the 10.
And then 2 by 2 gives you the 4.
And now for the punchline. Now for
Odd
the,
numbers.
these are all, so I can generate all of the what? All of the even numbers. I can generate it like this.
Starting from 4.
Right? And now, what if I do the same technique we were doing now? So the 3 by 3 took us to 6, 4 to 8, right? The 5 by 5 will take us to,
10.
and what if I do this now?
9.
And what if I do this now?
11.
Whoa! So now, the 6 has taken me to 9, the 8 took me to 11, the 10 will take me to 13.
we had the same.
Oh yeah, then.
So now, I can generate all the even ones.
Oh yeah.
Starting from 4.
Yeah.
So all I have to do is, if you give me an even number, if I give you 2018, what will you give me? Can you do it?
For what?
2018.
Oh, you get,
So
what's
you
the
get a
closest
remainder
square?
two. You get a remainder of two, so that means it would be.
No remainders. We don't need
No,
remainders.
no, you find the largest square closest to the.
1009 by 1009.
What are you doing to get that number?
Dividing it by
You're just dividing it by 2. So you divide it by 2. So you start out with a 1,000. So this is my square is 1009. So I have 1009 here, 1008 here because I don't want to count this again.
Yeah.
And then
And
this
you have
big
one more
one
square.
will give me that. And if I want an odd number,
Then you have to do.
Then you have
You
to
have to
make
yeah,
a
then you have to
square cut.
subtract.
No,
you
you make
make
a
the
square
square
cut.
subtract 3.
you subtract 1, or you can subtract 3, whatever you want. You can subtract 1, you can subtract 3, as
You
long as
can
you make the
add-
adjustment that you need.
It's easier if you subtract 3 because then all you have to do is add a plus code.
Yeah, I like that. You want to add your plus cut. So Varun is saying if you start out with it. So my question was 2019. Varun is saying take out 3.
Yeah.
So take 216. How do we do 216?
1008.
1008 times 1008.
Yeah. And then add the plus cut to one of the squares.
And then this is 2016. You make the or the big one. You just
And then
take
you
the big
add
one.
3, so it's-
Yeah.
The big one will give you, and then we are done. And in this case, you can see like if we were to, this was the idea. So if we have, I mean, this one only has what? 3, 6.
It has 19 by
7,
15.
8, 9.
It's a 19.
By what?
19 by 15.
15? Okay, so we can do 15 by 15.
cut off 4.
Cut off 4. Cut off 4. So if I were to cut, so I have my square, that would be a bit bigger scissors. So I have, and so my problem with the tiny squares is kind of so I don't need to at least iterate that cutting part. So I have this is my 15 by, how many am I going to generate with this one?
15.
15 by 15, I'm going to generate what number?
30.
30. So I'm going to generate 30. I have my 15 by 15. I generate my 15 squares. I have my, so I have my, all of these here. That's why you guys didn't need color, but it's good. So I have my 15 and I have 14 that I'm from this side. And I have my big one that's 30. But if I want to cut my big one, so I can just cut my big one in 4.
Couldn't you also cut it into 14 by 14?
Yeah.
You could get a lot.
Yeah, of course. Yeah, we can continue to do. And then we have our, is this 3, 7, 7 times 7. Good. So we have, and this same idea we can continue to do. So I like this approach because it's just 2 sets. Even numbers, odd numbers.
And
That one is also good.
And plus 3.
What
Add
was-
3.
Yeah,
So you
exactly.
can get
And include 1 because you start with 1.
Yeah, so that's why, I like this approach, although that one is excellent as well. And we can continue to play with this problem.
How would it work for -1?
What do you mean for minus
You
1?
You
work?
subtracted 3 from 2019 and then
If you want to do 18, no. Varun wanted to subtract 3.
you
Because
wanted
it's
to
odd.
subtract 1.
Let's see, but if I subtract 1, you're right, I'm going to end up, you're right. If I subtract 1, let's see, I end up with 109, 1009, and 1009 also in there. So what do I have now? 1017. Yeah, you are very right. Yeah, we need to subtract 3. Good.
Because of the plus cut.
Yeah, because of the plus cuts that Varun has so interestingly named. So we can do a lot with this program. I thank you guys. I think you were great. What do you take from this? Do you want to share something? What do you think about the problem? What do you think about how we did it? How would have you done it differently? I don't know, whatever you want to share.
So I would have probably done the method that we have used earlier, and then like first I just found out the way we can add 3, but then with the help of other classmates we could find out other ways to find out other multiples of 3 and derive a formula that any number greater than 6 can be divided into that many squares. But I also like this solution as it was very interesting.
It's just different ways. George Paulet used to say that it is better to solve a problem, to show you how to solve a problem in 5 different ways than to five different problems the same way. Okay, so when I look at problems, I like to try to explain them in different ways. They each show something.
Yeah, like a great takeaway for everyone, maybe like the next time we look at a square, we're gonna be like, oh,
Okay.
we can
Okay.
cut it in 20 different ways.
And I have more problems with squares that lead to, if you want to, read a little bit about polyominoes. But another takeaway is these are great puzzle books. We're actually getting another one ready for a festival. So each of you can take one of each. Each of you can take one of each. I am the director for the Julia Robinson Mathematics Festival. We do them now across the U.S. and now we are, actually we're planning quite a few in India right now. So the ones in Bangalore and Mysore seem to be taking shape in January. We're going to go to Vrindavan. It's one of each. We're going to go to Vrindavan. Maybe April, maybe June. We have Hyderabad, right? And we
Or this is the
have
one with squares.
Lucknow. So there's something going on in Lucknow. What happened? They're supposed to be.
You're out of blue.
We're out of blue ones. We are? We're out of blue ones. We are out of blue ones. Yeah, we're out of blue ones.
You said
Yeah.
blue ones?
Yeah, those are the blue ones. That's number what? Number 2. It's okay. So we're out of blue ones. They are online. These books are online.